Section 3.3, we're looking at chords, and there's some theorems and properties that deal with chords that we're going to look at. So just remember a chord, you have two endpoints on a circle, and it's the line between them. It's always a straight line. We're not curving it. You could draw it with a ruler. An inscribed angle is when you have two chords that make an angle between them. You could also have an angle made from the radius. So because it's inside the circle, we call it inscribed. So here's our theorems for this section. There's 4 of them. The first one, if you have two angles that they're inscribed by the same arc, then the angles are congruent. So see how this angle makes that darker arc? This angle also makes up that arc. So because this arc length goes to both angles, the angles are the same. And you could see that just from drawing the angles and the lines and the chords. Our second one, two chords of a circle are congruent if and only if they are equidistant from the center. So here's the center, and there's two chords, A, B, and C, D. See how they're the same distance away from the center? That means that the arcs are the same. So AB is congruent to CD because the distance from the center is the same. Okay, if two chords intersect inside a circle, then the products of the lengths of the segments of the chords are equal. And we actually don't use this one in this section, but it's just a good theorem to know. So each side is congruent. So AE is congruent, or not congruent, you multiply them. And then you multiply DE and EB, and those are the same. So it's the products. Oops, I thought I had the eraser. I wasn't trying to cross it out. It's the products that are the same, not the length of the chords. So product means multiply. Okay, this one is in this section, Theorem 5. If one chord of a circle is a perpendicular bisector of another chord, then the first chord is a diameter. So this one we're going to see in here, we have the diameter of a circle, so it goes through the center. And then there's a chord that cuts that diameter at 90 degrees. Because of that 90 degrees, each side is the same length. And because those sides are the same, the arcs are also the same above the cut. So that one we're going to see mostly in this section, and you're going to be solving some equations related to that.